Thank you. And my presentation will be about evaluation of the possibilities to use compactless harvester in commercial cleanings. On the earlier studies on the use of compactless harvester in pre-commercial thinnings in Latvia mainly were aimed to forest biomass production. Pre-commercial thinning of young stands where the characteristics of the stand are not sufficient to be produced of the biomass. Forest biofuel, it is still mainly carried out with hand tools, which can be explained by lower costs and smaller efficiency of mechanization solutions. During the recent years, the lack of labor of manual work has become increasingly obstructive, which significantly affects labor costs and timely implementation of the operations. Therefore, the question of mechanization of young stand thinning without biofuel production is becoming more and more relevant. And aim of this study was to analyze the feasibility of mechanization of the pre-commercial thinning, looking for the most suitable solution to replace manual work in young stands where forest biofuel production is not possible. And we selected forest stands with tree height from 2 to 4 meters. This study was done in 2019 in period from January till March in central part of Latvia. And we selected 10 forest stands in areas measured by Joint Stock Company Latvia's state forests. And in total, thinning was done in 30.3 hectares of young stands, and studies were conducted in forest stands where the dominant species were coniferous. And in these studies, compactless harvester VMEC was used, and 2 experienced operators participate in this study. And we compared 2 harvesting heads, from which the first was Cutling harvesting head, and the second was VMEC C12 harvesting head. And using VMEC harvesting head, 2 working methods were compared. And if the distance between rows, 3 rows, was 2.1 meter, the movement of the harvester was organized perpendicular to the 3 rows. It was the first working method. But if the distance exceeds 2.1 meters, the movement of the harvester was organized between 3 rows, and that was the second working method. And I should add that in this working process, using Cutling harvesting head, just the second working method was used. And here we have some results and distribution of productive time depending on used working methods using VMEC harvesting head show that if using the first working method, most time was spent for felling phase, which could be explained by the location of trees, making the felling process difficult. But if using second working method, most time was spent for boom out phase, which could be explained by the thickness of the stand and the need to work with full boom. Although there are differences in average achieved productivity indicators, in the comparison of working methods, these differences are not statistically significant, and the results of studies show that it is important to evaluate the effect of the working method on the quality of remaining stand. Also, studies show that using first working method to ensure the movement of the harvester, there is a risk to that 1 row of trees will be completely cut down, leaving a thicker remaining part of the stand. Distribution of productivity time depending on used harvesting head showed that time spent in felling and moving work phases is lower using Cutling harvesting head, which is related to the different operational principle of the equipment. there are some average indicators of used working methods, and we can see that better results, I mean productivity results, are achieved using cut-link harvesting head, and the average productivity using this device was 0.12 hectares per productive hour, or 1 hectare per shift, and shift was 8 hours long. This proportion of productive time and total time was quite good. It was 90%. Using VMAC harvesting head, these results are not so good, but not bad, I would say. And the productivity was 0.11 hectares per productive hour, or 0.9 hectares per shift. But I should add that operators, that the first performance done with these differences, harvesting head was done with a VMAC harvester, and the second performance was done with Cutlink. That's why these operators were using this Cutlink harvesting head were more experienced, and maybe this affects this average productivity indicators. Yes, of course, if we are talking about young stand thinning, then a very important factor is work quality. And it is always a little bit a challenge. And for VMAC harvesting head, the challenge was height of remaining stems. And the second challenge was stem damage after attempting to fell trees too high. But for cut-link harvesting had one challenge was incompletely felled stems, as you can see here in pictures, and damaged remaining trees and uprooted trees. And of course, important factor is costs. And talking about these costs for commercial thinning, then better results are achieved using a cut-link harvesting head, but calculations show that by planning the maintenance of stand as a minimum a number of trees, costs can be reducing to 33%. And here we have some conclusions. The study results proved that the best productivity indicators were achieved in the areas that corresponds to application of the second working method using cut-link harvesting head. The productivity of mechanized pre-commercial thinning is significantly affected by the number of remaining trees. Bigger number of remaining trees means smaller productivity. Therefore, the thinning should be done as intensively as possible in accordance with the requirements specified in the regulatory acts. Average cost of thinning of 1 hectare using cut-link harvester head is by 8% smaller compared with VMAC harvesting head. However, it is still almost 3 times bigger that costs using in thinning using hand tools. In order to introduce the mechanization of thinning of young stands, it is also necessary to review forest management requirement, which is currently adopted to the use of hand tools. And thank you for your attention.